Hello everyone, welcome to my class. In today's class, I'm going to cover average value of a functions. So let me start the class right away. First, quick recall. The average value of finitely many numbers is computed by, first we add the total numbers and we divide the total sum by the total numbers. But the question arises here, how to compute the average value of infinite many numbers. For example, how to compute the average temperature during the month of June. So the temperature recording for the month of June may be infinitely many. So the idea is, we take a sample of temperature recording on every day, so there are 30 days, then we find the average of 30 temperatures recordings, so which is the sum here, and we divide by the 30, and then this reduces to in the form of here, which is the Riemann sum from calculus 1, if you remember. And if we consider the temperature recording by every hour during the month of June, or by every minute, or by every second, then I need to take n goes to infinite. I do have infinitely many temperature recording for the month of June. Then that converts this sum to the definite integrals. So that means we can define the average temperature during the month of June by using the definite integrals. So let me give you the definition of average value of a continuous functions. By the way, the temperature function I discussed here is a continuous function. Okay, so the definition here, the average value of a continuous functions defined on closed interval AB is denoted and defined by average value of f equals to 1 over b minus a times the definite integrals of fx from a to b. Great. So let's move on. Next, let me state the mean value theorem for integrals. It says, if f is continuous on closed interval AB, then there exists a number c in between AB such that f of c equals to the average value of the functions. So the proof is almost straightforward. Since function is continuous on closed interval, f attains its maximum and minimum value. That means the average value of the function lies between f mean and f max. Then by intermediate value theorems, we can find a number c somewhere in that interval AB such that f of c turns out to be the average value of the functions. Great. So let's move on. Maybe here, if you multiply both sides by b minus a, then this turns out to be f of c times b minus a equals to the definite integrals of fx from a to b. So then I draw the diagram here. So it says here, the geometrical interpretations of mean value theorem, it says, for a continuous functions, there exists a number c in between AB such that the rectangle with the base AB and height FC. So here, this is the continuous functions defined on closed interval AB. We can find a number c in between AB such that f of c is the height of the rectangle with the base AB. Then you can find the area easily. F of c times b minus a, which is this one here, has the same area as the region under the graph of f from a to b, which is the area given by the definite integrals. So that means the area under the graph of f above the x-axis bounded between x equals to a and x equals to b is equals to the area of this rectangle whose height is fc and whose width is b minus a. So the area of this rectangle is this part and this part, and area under the graph of f is this part and this part, so this extra part may be equal. Great. So now let's do some example. First example, find the average value of functions. Function given as fx equals to 3x squared plus 8x, defined on -1 and 2, and the interval -1, 2. So let's use the formula. Let's begin the solutions. So average value of functions on -1, 2 equals to 1 over b minus a, definite integrals of fx from a to b. By the way, our a is -1, b is 2. So 1 over 2 minus 1, 1 minus from formula, 1 minus given. So we have 1 over 2 plus 1. The definite integrals -1 to 2 of 3x squared plus 8x dx. Then we can easily integrate this integral. So the constant 1 over 3 as it is in the next step. The integral of 3x squared is simply x cubed, because x cubed over 3 cancel, plus integral of 8x becomes 8x squared over 2, so 2 cancel 8 4 times, so 4x squared, limit from -1 to 2. And in the next step, evaluate this expression at x equals to upper limit 2 and x equals to lower limit -1, and subtract these two values and simplify. It gives us 7. So our average value of given functions on given interval is 7. Great. Let's move on. Example 2. Find the average value of functions. The function is e to the sine x times cosine x on interval 0 and pi half. Let's begin the solutions. So we have average value on 0 pi half equals to 1 over pi half minus 0. Definite integrals x equals to 0 to pi half. The function as it is. Let's evaluate these integrals. So this integral is a good example for u substitution. So put u equals to sine x, then take the derivatives, du equals to cosine x dx. Then in the next step, let's rewrite this integral in terms of u variable. So 1 over pi half is 2 over pi. Then the integrals, e to the power u, sine x is u, so eu, and times cosine x dx. Cosine x dx is du. Great. The next step, 2 over pi as it is. Integral of eu is eu, and these are the limits of x limit, so x equals 0 to pi half. In the next step, let's resubstitute our variables. U equals to sine x, so 2 over pi as it is, e to the power sine x, x equals 0 to pi half. And the last, the 2 over pi as it is, put x equals to pi half, sine pi over 2 is 1, so e to the 1 is e. Put the lower limit, subtract, so minus e to the sine 0 is 0, so e to the 0 is 1, so 1. So our final answer is 2 over pi times e minus 1. Great. Similarly, let's move on. Let's do another example, example 3. In a certain city, the temperature in degree Fahrenheit T hours after 9 a.m. was modeled by these functions, which is t equals to 50 plus 14 times sine pi t over 12. The question is, find the average temperature during the period from 9 a.m. to 9 p.m. So during the period of 12 hours. Great. So let's begin the solutions. So to find the average temperature, I do need a closed intervals where I can take the definite integrals. So let's first discuss the closed interval here. So here t equals 0 corresponds 9 a.m. and t equals to 12 corresponds 9 p.m. So our interval is 0 to 12. Great. Then by formula, average value of the temperature equals to 1 over, this is b minus a, which is 12 minus 0, definite integral 0 to 12 of our given temperature functions, which is 50 plus 14 times sine pi t over 12. Now let's integrate 1 over 12. Integration of 50 is 50t. Then 14 as it is, this minus comes from sine, so the integral of sine is cosine, so sine pi t over 12 becomes cosine pi t over 12. and then times, we need to manipulate this constant. We need to divide by pi over 12, which is same as multiplying by 12 over pi, and then limit from 0 to 12. Great. Then in the last expression here, evaluate at t equals to 12 minus evaluate this expression at t equals to 0, and add and subtract. It gives us this answer, which is 50 plus 28 over pi. But this is a question about temperature, so let me give you the approximate answer in terms of temperature, which is 58.91 degree Fahrenheit. But in the exam, you don't need to give me this final answer here in terms of decimal. You just stop here, 50 plus 28 over pi. Great. So we finish these sections 6.5, as well as we finish this chapter 6. Thank you.